HR analytics requires us to use the scientific process, the scientific method, right? And we've all learned this in grammar school, reinforced in high school, and of course, nonetheless, you've probably taken science courses and learned this in your courses here in college. But let's start with step one of the scientific process. What's the problem? What's the issue you're trying to solve? Is it a turnover problem? Is it a motivation problem? Is it an engagement problem? Is it a legal problem where we have constant problems with people engaging in illegal or unethical behaviors? Doesn't matter what it is, we need to figure out what the source of the problem is, and we need to be able to properly identify the problem. So again, it's a very rigorous framework that tells us we have to be able to identify the problem in order to be able to collect data, analyze it, and then interpret it. So we have to start with figuring out what it is that we're looking at and what it is the problem that we're trying to solve. Next, we have to do some background research. And here's the thing, we don't want to recreate the wheel. There are tons of people out there, myself included, who are doing regular research that shows A causes B or C has an impact on F. And what does that all mean, right? So you've got to do your background research. You've got to understand the theories. You've got to look at what people have done, why they've done it, and where that leaves us in terms of predictions and understanding of what's going on in front of us. So you want to improve turnover rates and increase retention and decrease turnover, you need to do some research to know what kinds of practices, what kinds of best practices have an impact on turnover. Now that we know what the research says and we know that we have identified our problem, we have to make a prediction. And so we might say, based on what I know from the research, based on what I know to be the problem in front of us, I believe that this will have an impact on this. This will cause this to go up, this will cause this to go down, and these are the things that I need to do in order to be able to better predict what the outcome is. And so we are trying to make an educated guess, not a hunch, but based on sound research that A causes B. This is what I think is going to happen. If we do this, we should see this impact. And again, it's an if-then statement, right? If we do this, then this will happen. Then we have to test the hypothesis, and we do this in a whole bunch of different ways. We can do observational data where we do focus groups and we ask people to answer a bunch of questions. We observe their behaviors. We could do an experimental design where we have a control group and an experimental group. We will do what we call random assignment of conditions. And random assignment of conditions, statistically speaking, is a way that we can control for all sorts of variables that are going to have an impact on the study, right? So if I want to prove that A causes B, but there are a lot of other variables that could also have an impact on this, I want to be able to control for those additional variables. So when I randomly assign people to experimental conditions, one person in the control group, another person in the experimental group, we can better manage that. We can control that. There are things like pre or quasi-experimental designs. Again, all sorts of different ways that we could manage control groups, and we can have any combination of control groups and experimental groups. We can have one group that is control in sort of the pre and the post. Then we can have experimental in the pre, but not in the post. And again, the design depends on what it is that you're trying to predict and what resources you have available to you. There's a lot of research that's been done on quasi-experimental designs and experimental designs, and it's important to know how that works. And I will provide some resources for you in our course shell. And then, as I said, observational, right? Where we can take a survey or we will observe people, we record what the observations are, what we see people do. But no matter what it is, we need to have a way to test the experiment to see, did A cause B, in fact. In the testing process, again, we have to remember whether we're looking at qualitative or quantitative data. Quantitative data is a much more rigorous process, but qualitative data gives us a lot of opportunity and room to ask a whole lot of different questions. So quantitative, as we've already shared, is numerical in nature. It can be counted, it can be measured, it is representative of the variable of interest, whatever that might be. So if your interest is satisfaction on a 0 to 10 scale, how satisfied I would approximate I'm at a level 6, or I'm a level 2, or I'm a level 10. I'm very satisfied, I'm not satisfied at all. The qualitative is the descriptive. It is gives us an understanding of not just the what, but the why. Right? So we want to know the why. We want to understand the context in which someone made a decision and understood why they say they believe what they believe, and understanding that is important. And lastly, we're looking at big data versus little data. Big data is something you hear everybody talk about all the time. It's basically a massive amount of unstructured data that has no rhyme or reason to it. It's just a volume of messy data, and the goal is to narrow your variables and to clean the data up and figure out what's relevant and what's not. And sometimes that data comes from sources that we sought out, and sometimes it comes from sources that were not intentional at all, but we end up with the data anyway. And then little data is the structured that we collect for a particular purpose. Like, we can get massive amounts of data and then try to sort through it, which is the big data thing. But the little data is, yeah, I want to know how A causes B. So I go and I collect A and I collect B, and I look at the relationship between the two to see what the theory would predict would happen, and then what the statistical analysis would predict what would happen. And so we have to test it, and then we draw our conclusions from that.